methods from the Create Lab. So far we've, this semester, again, we're focusing on analyzing large corpora of text data. We've done the crowdsourcing and the code mapping, and those are both available on my website in the resources tab. Today, we're going to cover text mining basics, and then next month, we're going to be doing some sentiment analysis based off of today's. So just as an agenda, we're going to do a quick overview. We're going to talk about quantifying text with text mining. We're going to walk through the learning analytics process, and then there's going to be an example. Now, this is way too much to do in an hour, so I'm going to give you some background, and then I will put the example online for you to kind of work through, on your own, and I'm always available to answer questions if you email me. And so I'll have all this up in the next couple of days, by the end of the week. So text mining basics. So first of all, I want to say that this work comes from the Laser Institute, which I've had the opportunity to participate in a couple times. And so that stands for the Learning Analytics in STEM Education Research, sponsored at North Carolina State University. So there's their logo. They've been gracious enough to allow me to share all the materials that I was able to do at their institute. So I want to give credit where credit is due. These labs, I've kind of taken some and worked around it, but this work comes from that particular institute. It does use R for coding. And then, so those that are familiar with R, this will look familiar. For those aren't, we can talk through some things. And so you can use R, like if you have it downloaded on your computer. You can use Posit Cloud, which is how I'm going to be using it, or like an R Studio, which online or on your desktop. And my suggestion today is that you watch today, you determine your interest, and then you can sign up again for the next workshop and kind of walk through this to kind of gain some understanding. I will say this first lab, just to kind of give you a basic introduction if you're not familiar with R, is a little trickier than the next one. I will say this too. I'm a pragmatist. So when do I use R? When I already have the codes for something. When do I use Stata? When I'm doing multi-level modeling, because that's how I was trained. When do I use, like for ANOVAs, I was trained in both R and SPSS, and I prefer SPSS. So again, I'm not saying go out and learn R. I'm saying that I have some codes to help you do this. I do not know how to do it in SPSS, or if that's even possible. That's something, I really want to look into. And so again, that's, I'm able to copy and paste the code that's there, but creating my new code is not a strength of mine. It's not something I really want to spend my time learning. I'll just learn how to do it in SPSS, which I think is more user-friendly. So what is text mining? So we talked about code mapping last time, which was much more qualitative. And so text mining is about quantifying the text, quantifying what a document is about. And so this includes text pre-processing. We're going to look at word counts, term frequencies, TF-IDF, word clouds. So all of these are ways that we can pull out some meaning from a large group of text. And so most of the citations and most of the work come from this link or come from this resource. In the link, which again, these slides will be put on my website. You can access the entire book from this link. It's very nice. And then the chapters, they have whole chapters on different things. But it is with R, so it does kind of provide a little bit of more background in that. So let's talk about, again, the Institute was focused on STEM education research. I know I do a lot of STEM stuff with my math background, and other professors do too. So I want to give you an idea of like, how can I use text mining? So one, we can use text mining to evaluate academic performance. So we can assess essays and online assignments. We can look at writing styles. Are they using argumentation, plagiarism detecting, peer interaction? You can provide student feedback based on the interactions or the activities that they do in like intelligent tutoring systems. You can assist teacher feedback or support formative feedback. And then support student engagement and collaboration with automated writing scaffolds. analysis of interactional resources and student sentiment extraction. Oops, sorry. And then there's some other uses like automatic text summarizations, analytics and visualization tools, curriculum adaptation or adaptation, and recommendation systems. So let's talk about quantifying text with text mining. So here are some different text mining measures, and we're going to talk about all of these today. So word count, which is pretty self-explanatory. Word is how many words did they say, right? How long is an essay? Term frequency, which is the raw count of the tokens in each document, and we're going to talk about what is a token. IDF, which I actually, now that I think about it, I don't know what that stands for, but IDF. Measure of how important a term is, so not just how often it's used, but how important it is. And then TF, term frequency, IDF, is how important a word is to a document in a collection of documents. So you can see it starts very broad and it gets more specific. So there's a link in here that has a lot more examples and explanations, and I'm actually going to use this website to pull out and talk about each one of these. So a word count. So let's say you're taking these 3 reviews. Again, please do not have 3 sets of data, 3 little items of data and say, I'm going to do text mining. This is just an example to kind of help us wrap our head around this. So I have these 3 reviews. The Halloween thing was just lucky, like that I was not meaning to line up, scary and spooky. So what word counts would look like is that review 1, you would literally just count the words. And so review 1 had 7 total words. Review 2 had 8 total words. And review 3 had 6 total words. You can see that is was used twice. I mean, we're going to count it both times. And very was not used in the second review, not used in the third, but was in the first. So this kind of shows us the overlap of the words when, I mean, you obviously could have just counted 7, 8, and 6. How many words? So this could be useful in like looking at student essay or student responses. Again, it all comes back to your research question. Not the most exciting one, but it's there. Review 2, or sorry, term frequency, again, using these same ones, is the raw count of the tokens in each document. And so here the tokens are going to be words. And we're going to talk later about how tokens could be sentences or things like that. And so here you're going to do the number of times a token occurs over the total number of terms in the document. So if you remember, our totals were 7, 8, and 6. So here, this shows up 1 time in review, the first review. So it's 1/7 of the total text. Whereas, and it showed up in 1 in each of them. So it was 1/7 from review 1, 1/8 of review 2, 1/6 of review 3. Super exciting stuff, I know. But how often do the terms occur within each of the documents? And so here, a token is going to be at the word level, and a document is going to be each review. You could do document, could be a whole essay. A document could be one person's interview. Okay, so you're going to define that. IDF is how important a term is. So kind of similar is you're going to do the log function, everyone's favorite mathematical function, of the number of documents divided by the number of documents with the term T. So again, this was in every single one. So the log of, so, okay, I'll give you an example, my bad. So is. So here, is showed up in every single review, right? It showed up in the second one twice, but we just care about like how many it showed up. So I had 3 documents, and then 3 of those documents had the term is, and the log of 3 is log of 1 is 0. So that shows us that the word is not important. When you were reading those reviews, did you say, wow, their use of the word is, that will help me distinguish something? Probably not. However, let's look at the word spooky. So here, the log, it showed up, I put those upside down. I had those backwards. That's why it was negative. Should be 3/1. There are 3 documents, and the number of documents with term T is 1. So then that gives us an IDF of 0.48. So you can see it helps us look at different letters. Now, if you look, scary showed up twice and has a lower IDF because it's less distinguishable. So for example, if I'm giving you all an essay and every single person in here used the word scary, scary doesn't help me distinguish between your different essays. If all but one of you use something, again, similar, it's not that distinguishable. But if only one person out of all of you used a word, I might want to look at how important or distinguishable that word is. So it kind of, this one uses a kind of comparison and again, a part to a whole. And then the IDF is the measure of how important a word is to a document or a collection of documents. And this is actually those 2 things times each other. So again, looking back here, the 1/7, 1/8, 1/6, and then you're multiplying that by the previous one. So if the IDF was 0, when you multiply it by 1/7, it's going to be 0. So here the IDF was 0.48. And when you times it by the 1/7, you get this, and you times it by 0, you get this. So this kind of shows it's combining 2 things. It's how important it is, but it's to the specific document, not as a whole. So this helps me compare within a little bit better, whereas the other one is more between. So within a document, how important is your word versus across documents? All right, so these are the kinds of things when we're doing text mining, you're able to pull out and you get numbers here, right? So the one thing this very different about this than the one we did a few weeks ago is the context. Because if you're just looking at this, I mean, you can probably gather if this is a review, this movie is, but you do lose sight of the bigger data. Whereas with the code mapping, it was always kind of there and you're very much in tune to it. You're reading every single one. Here, you're really extracting numbers from the data. But before we get into actually how to do these things, I want to talk about the learning analytics process. And so again, this is just a broad overview. If you are more interested in learning analytics processes, and there's multiple, so text mining is just one of them, machine learning is another, and I know that course is being offered here next semester with Dr. Kutsumishu. So these are things, if you're interested in this, you know, there's a lot of opportunities out here to learn more about this. So the first thing is to think about the learning analytics workflow. And so this data, and I put the citation on a second, kind of shows the process of how we get from the data to the results, or to the articles, to the writing. So the first thing we want to do is prepare. I'm gonna go over all of these. Then we're going to wrangle the data. We're going to explore. We're going to model the data and then communicate. And you can see it doesn't necessarily happen in a straightforward. There's always kind of circling back. We might find some things that we need to look at differently or et cetera. So in the prepare stage, you're looking at the context, the research questions. This is when you want to load in the packages, you want to read in your data, and you want to familiarize yourself with the data. What are the variables that you have in your data? You know, and again, if you're doing this in SBS, this is true if you're doing it SPSR, but you need to think about your research questions and what you're trying to do. If your research question lends yourself to a frequency, then you want to do that. If it lends itself to something else, you would go in a different direction. So next, you want to wrangle your data, and this can take on a variety of things depending on which learning analytics process you're going to use, but I'm going to talk about text mining. So here are the different things, different way we can kind of wrangle our data and kind of get it in a way that is usable. So that's what we're going to do with wrangle. So the first one is tokenization. And so tokenization is the process of splitting text into tokens, which I briefly mentioned, which are meaningful units of text to be used for analysis. And when you have your data, which is usually in an Excel file, you want one token per row structure. So if you have that whole sentence up there, it'd be the process of splitting text into. So you want to be able to take a paragraph or whatever it is and separate it into the token. And that token could be a single word, but it can also be an n-gram, which it could be like n could be any number. It could be a 2 or 3, 4 words. It could be a sentence or a paragraph. And then the R code that we're going to use for this is unnest tokens. And so for those of you not familiar with R, there are ways that you can type this in and then ask it to tell you, what is this? What do I need? What kind of data or what kind of variables do I need to punch in so that you can actually do it on your own? But again, I'm going to give you the code that you can use as a jumping off point. So then there's also stemming, which reduces the size of the vocabulary in the text by conflating related words. So for example, so what it does is it converts the word with the same stem or root. So creative and creator are going to be seen as separate, but you might say, well, they have the same meaning, and so we can stem them to form a single word type. And again, you're going to use the word stem R code for that. Now, there's some shortcomings with that, right? Because as we know, especially in the English language, a lot of words look the same but mean very different things. So, for example, mean, average versus meaning, they look like they have the same stem and they might be put together when they actually don't mean the same thing in the context of the problem. So again, these are things to think about. Then there's stop words. Stop words are words that don't add much value to an analysis. Anybody have any suggestions for what that might be? Give me a stop word. It doesn't help. But no. What? No. Well, it depends. Again, and it depends on context, right? So could be. But the big ones are and, the, of, and to. And we know it puts words together. The is the most common, right? So what you can do is you can do anti-join, whatever it is your data frame is, and stop words, and it's part of the tidy text package in R, and it will remove the stop words. Because I don't need to, I don't need to know that the people I interviewed said 50 times. Then, that's not an important word, right? And so these are actually already in a package that's already predefined, but you can add new ones that are specific to your context. You can also take ones out that when you do the explore and you see like, why is this one included? Oh, because in our context, it means something very different. A few years ago, when AERA was online, they had some issues with the lobby. I don't know if anybody here went to that, and they couldn't get in and out of the lobby. Well, when we talk about this next week, lobby has a negative value for sentiment analysis, and it was throwing everything off because it's like lobby from a political standpoint. And so the people running an analysis decided that they wanted to put lobby in the stop word because it was just throwing off their data. It wasn't being used in the right way for this context. So again, that's why you want to maybe circle back from when you start to do the exploring phase, you might say, oh, I need to go back and add some more stuff and recalculate. And then there's filter. So you can pick cases or rows based on their values in a specific column using the filter. So this is from the Dippler package. So for example, you might want to filter by, if you're interviewing, you might want to filter by pre-service teachers versus in-service teachers. Or you might want to, if you're looking at all your data together from all your classes, you could filter by different, like your first period versus your second period or your first class or whatever. So these are all ways to wrangle the data. So you've prepared the data, you've looked at it, and this is kind of reorganizing your data in a way before you actually kind of run some analyses. So then we want to explore. So we want to do calculating summary statistics, and that's when we might see some words in there that we didn't really look at, or we might see some interesting things that we want to consider in calculating proportions. This helps us identify common words used and to describe the most valuable aspects. Data visualization, such as word clouds, bar plots, and small multiple charts. So this kind of helps us get a sense of like what we're seeing. And we'll talk about, you can actually use those in publication as well. But then really kind of understanding the patterns and trends that would be difficult to distinguish otherwise. And then feature engineering is the process of creating new variables from a data set. So it could be that you want to combine different things or you want to take apart different things. But here you can start to kind of think about, do I want to do something different? And then you might go back to the wrangle. So then in the Explorer, this is really important because text mining is fantastic and it's a lot of fun to do. But I think people have the misconception that it's like text mining is all I need to do. So in the Explorer, we identify patterns and relationships, but it's in the model phase that we actually use the data. So text mining is just going to help you quantify the text. It's going to give you numerical outputs, but you still need to actually run a model. So this is where you would say, do pre-service teachers talk more about technology than in-service teachers, right? And so then I could run a very simple, probably t-test at that point to determine those relationships, right? But the text mining, all it gives you is the frequency and the word count. You still have to be able to answer your research questions, et cetera, with a model of some sort. So using statistical models to determine if the relationships, patterns, and trends are actually meaningful. And again, t-test, ANOVA, mixed level modeling, really the sky's the limit. But this is when you have hundreds and hundreds of pages of transcripts. How do you get something quantifiable from this? And this is how you can do that to then run the tests. So I know we're not done yet. We're going to do communication. So hopefully you can see the difference between the code mapping. So this usually takes a lot less time than code mapping, but the code mapping is much more comprehensive, is in depth. Whereas this, you can likely miss something, right? And so it's important to kind of think about those limitations that can occur when you're doing this. And then the communicate. And so here you want to determine which analyses are the most important and most useful for your intended audience. Again, that should be based on your research questions. You want to choose how you display that information or a data product, and that could be a graph, a word cloud, etc. Then you want to polish. You want to spend time refining or polishing that, cleaning it up, adding, editing. Here's the fun part, all the labels, the notations, using the colors to highlight the different groups, etc. Then you want to narrate, which is just a fun way to avoid the word write. So you want to write a narrative to accompany. So this is how, this is for like publishing or writing a manuscript, is you want to select the analyses, you want to polish up the graphs or the products, and then you want to write a narrative to accompany those and pairing a data product with its related research question. And then again, describing how to best interpret the data product. All right, so before I dive in, do we have any questions here or online? Yeah.
about the lexical level, like measure the coherence or the syntactic complexity or the language sophistication, like based on the taxonomy process?
So the question was, because I don't think I'm not plugging into the mics here, is can you do more sophisticated things than lexical using sophistication and things like that? I think I'm at the point now with AI and learning analytics of like, can you do something? My answer is usually yes. Can you do it with text mining? I'm not sure. I know that some of the stuff that I learned about in the Institute, that we're going to do the sentiment analysis. They do topic modeling of like organizing it into, so basically kind of a coding. And then one of the things that was in the newer version that a little bit was more like text comprehension, which has that like added level to it, but it's a bit more complex. I will not be talking about that. This today is just going to be a basic of like, here's the overview. But if that's something you're interested in, we can talk about. And like I said, I can share these labs that you can kind of walk through it. And I will say the lab is not just, as you're going to see here in a second, a bunch of code. They really put some time into it of like here, and there's the open lab for you to try it yourself, and then also the keys, so that it leads you with like they put the narrative in there of like, here's why you do this and here's what you need to do. And so it really is kind of a self-guided thing. So I can make those available and you can try them on your own and see if that answers the question. I should have prefaced to say, like, by no means am I an expert in this. I've done it several times and I've worked with people who are experts. So I'm going to answer questions as best I can. And I do think that the resources available that are usually free online are really great, explanations and things. Yes.
In the example you shared earlier, there was one person said scary and another person said not scary. So could you count those as two different tokens? Is that an easy thing to do, or is it?
No. So that's where it gets tricky, right? And so there are ways to do it, and that's when you would get more at the n-gram kind of thing of like, you're going to look at a 2-word versus because again, that's very of like, if you're like, oh, did you like this? And someone say, I really like this versus not really, those kind of things. And that's one of the huge issues here, right? If I was coding that by hand, I would code one of them positively and one of them negatively, because as a human, I can use my context. I'm not saying it can't be done. It is a little bit trickier. I know that's something we worked on at the lab, and there are ways to do it, yes, but it's trickier. And like I said, the book that's in there has all of this in much deeper explanation. And so that's what I want today to be, is like, how interested are you in this? How can you get started, and give you some resources for that. Great question. That's a big one. I don't know if y'all could hear it. Sorry, I was supposed to repeat the question. The question was like, distinguish between like, what was your example?
The
scary versus not scary. And when you split up two groups are talking about scary, two people are talking about scary, but in very different contexts. Great point. Or in different ways. All right, so let's take a look at this lab example. Again, I'm going to make these available online. I want to clean them up so they're a little less scary. And again, all the credit goes to the amazing team at the Laser Learning Lab. I know that they just finished funding, but they're applying for more stuff, and they do workshops at the Learning Analytics and Knowledge Conference, which I think is usually held in March. But again, your suggestion today is to kind of gauge interest if you want to try to walk through these on your own. The good news is, like most coding, if you want to know if you're on the right track, hit run. And if it runs, you did it. If it doesn't, it doesn't. So you do get that kind of immediate feedback. And so this is Posit Cloud, which is where the different learning labs are kept. And so you can see in here, in this particular, again, this lab, there was different case studies, Machine learning was offered, network analysis was offered, text mining was offered, foundational skills, which really kind of gave that background in R. But then I've also created my own workspace and applied this to my dissertation and follow up with there. But going back to the laser learning labs, this is in the text mining. And again, I will share this. That actually might be the old one. Give me a second. This is the up-to-date one. So the Posit Cloud is a way it stores, but if you have RStudio or just the R on your computer, that's more than okay. And so when you open it up, the first code you can see, again, thanks to Dr. Shan Zheng, who helped organize all this and led the training at the Institute. And so this is what it looks like in R. It walks you through, it gives you all the information, and then at certain parts, you'll see a place for you to actually kind of like write in your own code. Now, again, this is there's case study, and then there's also keys. So the keys are going to be all kind of filled in. So I've still got to do this. I plan on giving you this kind of in a Word document, but then I'll also create something and share in Posit Cloud, but you will have to create an account. I just use my Google, but you'll have both. I just need a couple of days to do it. And see, the other thing too is to make sure you have all the packages in, those of you familiar with R. But again, you should be able to run all of these and it will work. But the great news is it also comes with HTML printouts of like, here's what it looks like. Isn't that nice? You don't have to go through the code. So this is kind of what the lab looks like. Now, and so I just want to go through this briefly to kind of show you, how do I do this in R? So again, all of this information. So when I copy and paste this into my own, I don't include all the background information. But I think this is great for your first time, just reading all this, understanding kind of what you're doing. This is where I got a lot of my content from. So again, at the prepare, if you remember, the big part of prepare is to read in the data. So you have to, before you can use any of the packages, those of you familiar with R, you have to tell it to pull in a library. And here, these were the two libraries that we used. It also doesn't hurt to just pull in every library you've ever heard of in case you need them. And so here, the Wrangle, again, we're going to be using all these. So we have to pull in the data. We have to kind of transform the data. And again, all of these names are going to be the names of the data that they have. So for this, and I skipped this, this has a specific context of the data we're going to use is about the North Carolina Race to the Top. It's a professional development initiative. So that's what this is real data that was able to be shared. And so the data comes from interviews, document reviews, site analytics, and surveys, which here, so this is focusing on survey data. So if any point you want to see like what this data looks like, you can go over here, or you can just, there's a bunch of different ways to do it, to view like what the data actually looks like. I can't find it. But you can look at all the different variables and things like that. And so again, there's lots of different things. This is going to read you, this is going to help you kind of go through. Oh, so here it tells you that there are 19 columns and 57,000 rows. So that's 19 different variables. And I don't know if that 57,000 is probably the number of people that responded to the interview or responded to the survey or something. And so again, you're going to read in the data. Again, I don't want to sit here and teach y'all how to do R, but I want to go through what you'll expect to get. And then here, as we start to do this, you'll start to kind of look at what the data is. here it tells you different positions. So this is a perfect example of like who's filling out this survey. Some are going to be superintendents, some are going to be counselors, some are going to be teachers. So you might want to filter just by teachers and only look at the teachers' responses, which would be different. And so this is just kind of understanding like what the data looks like. And so so the tidy text is the one that's going to unnest them and split the columns into tokens. And the anti-join returns all X. So in here, that's not the example I want to show. This is what it looked like before of like 1, 2, etc. And then now it's looking at one word at a time. So that's why it's the same. It looks like the same thing, but this one live teacher webinar code, it's breaking up into every single different word that they said. So that 57,000 is going to turn into a whole lot more. Here's where they remove stop words. It gets rid of the and, the, of, etc. The anti-join. And so here, going down to the explore, is when they did the word counts. They can filter and search for different words. So you can filter online. And then a data visualization. So a very popular one is word clouds. Now here, because the model, they refer back to, I think, the actual study. I'm not sure like which model they used, an ANOVA or whatever. But this kind of walks you through, how to do all this. So again, I don't want to talk about all of this now. I just kind of want to show you of like what this kind of looks like. And again, there's a lot of text on here that won't be on yours. But you can kind of see the outputs and, some of the different maybe questions you can answer in this. I will add that a lot of the studies I've seen don't use these analyses on their own. Again, this is just the basics to try to understand the more sophisticated analyses that you can do with it. So next presentation on sentiment analysis, you kind of have to understand a little bit of like, what are tokens, what are anti-joint, like those kind of things. All right, any questions? I know there's a whole lot of questions like what is happening? What am I looking at? Any questions? Yeah, if you're online, feel free to put it in the chat box. All right, so this might be something that you want to try on your own. And if you have questions, please feel free to reach out to me. Yeah, go ahead.
What is this, the name of this space? What's that?
So this is in Posit Cloud. What I'm going to do is I'm going to get it in a format where you can either, I'll either share it through Posit Cloud if you want to create your own. This used to be RStudio Online, and I don't know if Posit Cloud just kind of absorbed it. I also want to I'll do a printout so that if you want to just copy, if you have R already on your computer and you just want to copy over the text, I want to get it in a couple different formats. But this is just so that I can share it with you and then you can make a copy and do your own from there. And you don't have to download. I mean, it gets a little slow and wonky with the internet sometimes, but you don't have to download R if you don't already. I have heard of some people using, like, putting data and stuff into ChatGPT and asking it to do similar things. I don't know how well it does it. And the other big thing to think about is security. You should never, ever, ever just put data in a thing online without it being approved. And so our studio is one of those that's like, it's so maybe R on your desktop is probably a bit more secure, but something to just keep in mind. And if it's de-identified, that's also, ideal. Was there another question?
Okay, yeah, the lab will teach us the four different, like how to do the four different parts.
Yeah, so the lab walks through and it has the different like, so in the box is the kind of code, and then the outputs underneath. There's some comprehensive checks that kind of like help you think about it on your own. And so the steps I would do is walk through the lab, work out all the because there will be kinks. It's a huge learning curve when you're first using R. And then try to see if you can, like,